From the silence of space, our planet looks serene, a glowing blue sphere adrift in the endless dark. Every cloud, every ocean, every heartbeat below tells the story of fragile harmony. Yet in the vastness of the cosmos, this sanctuary of life is only a thin shell, delicate, exposed, and temporary. Beyond that fragile sky, countless fragments of stone and ice drift silently, remnants of creation itself. Most never reach us, but sometimes one does. Even a rock no wider than a city block carries enough energy to erase everything we've built. In the darkness, the cosmos is not cruel, only indifferent. 66 million years ago, a single asteroid changed the course of life forever. The skies burned, oceans boiled, and nearly all that walked the earth vanished. The age of dinosaurs ended in a single blinding instant, a reminder written in stone that life here has never been guaranteed. For most of history, humanity could only look up in fear and wonder. But today we are no longer blind. With telescopes that see beyond the limits of light, and spacecraft that touch the edges of our solar system, we are learning to track the messengers of chaos before they arrive. We are the first species to understand the threat, and the first capable of defending our world. In the darkness of space we have found both danger and purpose. Today we are not powerless. We are learning to see the threat, and act before it reaches us. Long before Earth was born, the solar system was a swirling ocean of dust, gas, and fire. From that chaos the planets emerged, but not everything found a home. Scattered between Mars and Jupiter lies a field of ancient debris, billions of fragments frozen in time. These are the asteroids, the leftover stones of creation, silent witnesses to the dawn of our world. Far beyond the planets, at the frozen rim of our solar system, lie the comets. Icy travelers from the Kuiper Belt and the mysterious Oort cloud. They spend millions of years in darkness before the sun's gravity calls them inward. As they approach, their ice begins to burn, releasing long glowing tails that stretch for millions of kilometers. Reminders that even in the coldest corners of space, movement never stops. Asteroids are mostly stone and metal, dry, dense, and ancient. Comets, in contrast, are fragile mixtures of ice, dust, and frozen gases. Asteroids circle the sun on stable, predictable paths, while comets travel on vast elliptical orbits, sometimes vanishing into deep space for centuries before returning again. Yet both can cross Earth's orbit, and when they do, the difference between a rock and a comet no longer matters. History reminds us how fragile our world truly is. In 1908, the Tunguska explosion flattened 2,000 square kilometers of Siberian forest, the result of a single cosmic object entering our atmosphere. A century later, in 2013, a meteor over Chelyabinsk shattered windows across an entire city. These were small warnings. But in 2029, a larger visitor, the asteroid Apophis, will pass closer to Earth than our communication satellites. Scientists classify these objects as near-Earth objects, or NEOs. Asteroids and comets whose orbits bring them close to our planet. Among them, a smaller group is called potentially hazardous asteroids, or PHAs. Bodies large enough to cause global damage if they strike. Every week, new ones are discovered. Each name added to the list is both a warning and a victory, because what we can see we can prepare for. Across the deserts of Hawaii, the mountains of Chile, and the plains of Arizona, robotic eyes scan the heavens every night. They belong to a network of telescopes, silent guardians that track the faintest moving dots against the endless stars. To the human eye, these points of light mean nothing. But to scientists, each one could be a messenger from deep time. A fragment of rock whose orbit might one day cross our own. NASA's Planetary Defense Coordination Office stands at the center of this global watch. Working with observatories like NEOWISE, PanSTARRS, Atlas, and the Catalina Sky Survey, they map the orbits of every known asteroid that comes near Earth. Each observation is compared against millions of previous ones. A constant search for new threats, small shifts, or silent intruders emerging from the dark. In recent years, artificial intelligence has become our most powerful ally. Machine learning algorithms now analyze vast streams of telescope data, detecting movements so subtle the human eye would never notice it. They predict orbits decades into the future, calculating which objects might come close and when. For the first time in history, humanity is not only watching the sky, it is understanding its patterns. Each asteroid follows the laws of gravity, but small forces, sunlight, radiation, the pull of planets, can bend its path in ways that are almost invisible. Astronomers run millions of simulations, adjusting for every possibility. What if the orbit shifts by 1 kilometer? What if it passes near Venus? What if? These calculations let us look years, even centuries ahead, turning uncertainty into knowledge and knowledge into protection. Not all of our watchmen are on the ground. In space, telescopes like Hubble, Gaia, and the James Webb Space Telescope provide a higher vantage point, mapping the faintest, most distant objects with precision no human could match. From this perspective, Earth's orbit becomes just another thread in the vast fabric of the solar system. And every potential threat, no matter how small, can be seen for what it truly is. This is not a mission of one nation but of all humanity. Through the International Asteroid Warning Network (IAWN) and the European Space Agency's Hera mission, scientists across continents share discoveries, refine predictions, and plan defense strategies together. It is a quiet cooperation, no politics, no borders, only one shared goal: to ensure that when the next cosmic threat is found, the world will already be ready to respond. For centuries, humanity could only watch the sky and hope. But in the 21st century, that changed. For the first time in history, our species decided to reach across millions of kilometers of space. Not to explore but to protect. The mission was called DART, the Double Asteroid Redirection Test. Its goal? To see if we could change the path of a cosmic body before it ever threatened Earth. In September 2022, the DART spacecraft, no larger than a vending machine, struck the small moon Dimorphos, orbiting the asteroid Didymos, at over 22,000 kilometers per hour. It was humanity's first deliberate impact with a celestial object. The collision released a brilliant plume of dust that stretched for thousands of kilometers. And when the debris settled, the impossible had happened. Dimorphos' orbit had shortened by 33 minutes. For the first time, Earth had nudged a world from afar. Scientists watched in awe. Telescopes around the world, and even the Hubble and James Webb Space Telescopes, captured the event in exquisite detail. 4 days they tracked the expanding plume, the dust trail, and the altered orbit. The results confirmed what had once been only theory: that we are no longer helpless in the face of cosmic danger. With precision, patience, and courage, humanity had moved a mountain in the void. But the story of DART did not end with the impact. In 2026, the European Space Agency will launch Hera, a spacecraft designed to revisit Dimorphos and study the aftermath up close. Hera will map the crater, measure the asteroid's mass, and analyze how the force of impact truly changed its motion. Together, DART and Hera mark the beginning of something extraordinary: humanity's first experiment in planetary defense. The success of DART opened the door to new ideas. Engineers now imagine fleets of kinetic impactors, spacecraft designed to strike again and again until an asteroid's course is safely altered. Others envision gravity tractors, massive ships hovering near a dangerous rock, using their own gravity to slowly pull it off course. And in laboratories across the world, scientists experiment with laser ablation, vaporizing surface material to create a gentle but continuous push. Different methods, one shared mission: to ensure that the next cosmic bullet never finds its mark. Planetary defense is more than science, it is a declaration of responsibility. For the first time, humanity has reached beyond exploration to the act of protection. The same curiosity that once looked up at the stars in wonder, now reaches out to defend the only world we call home. The message is simple: we are no longer at the mercy of the cosmos. We are its conscious part, aware, prepared, and awake. When a large asteroid strikes Earth, the planet itself becomes the weapon. Dust and ash are thrown high into the stratosphere, blocking sunlight for months, sometimes for years. Temperatures fall, photosynthesis stops, and life struggles in the dim light. Scientists call it an impact winter, or the more haunting phrase, a nuclear winter without the war. Such events have reshaped Earth's history before. reminding us that the boundary between heaven and hell can be as thin as a layer of dust. The story of climate is written in fire and ice. Massive volcanic eruptions, asteroid impacts, and cosmic dust have all changed the rhythm of our planet's temperature. Some events plunged Earth into deep freeze. Others released greenhouse gases that turned it into a furnace. Every shift, every extinction, carries traces of both cosmic and terrestrial forces, proving that our planet's climate has always been a conversation between Earth and the stars. Today the watch continues, not from the ground but from orbit. Satellites like NASA's Aqua, Terra, and Suomi NPP circle the globe every day, measuring clouds, carbon dioxide, ocean heat, and even the faint glow of city lights. They see what we cannot: slow changes in the atmosphere, invisible currents in the oceans, and warning signs of a planet under pressure. From hundreds of kilometers above, they give Earth a mirror, and humanity a chance to understand itself. These eyes in the sky do more than watch, they warn. By tracking temperature patterns, polar melting, and atmospheric shifts, satellites help scientists predict hurricanes, droughts, wildfires, and floods long before they strike. Each signal, each image is a message from the future, telling us that our survival depends on listening to the data written in light. But not all change begins here. The sun's magnetic rhythm, bursts of solar wind, and cosmic rays from distant stars all influence Earth's atmosphere in subtle but powerful ways, altering cloud formation, ozone levels, and the energy that sustains life. The climate of our world is not an isolated system. It breathes with the cosmos, and in that breath lies the story of every storm, every season, every dawn. For most of our history, the cosmos decided our fate. A random rock, a silent orbit, a star's flare, any could erase the fragile story of life in an instant. But now, for the first time, we are no longer passive. We have learned to see the threat before it arrives, to understand the laws that once ruled us, and to answer, not with fear but with knowledge. Through telescopes, cameras, and spacecraft, we have turned the universe into a mirror. Every discovery reflects a single, deeper truth: that we, too, are part of this cosmic machinery. The dust that forms the stars is the same dust that built our bones. When we look into the night sky, we are not just exploring the universe. We are remembering where we came from. With this awareness comes responsibility. We are the first generation capable of saving the planet from a cosmic impact, and perhaps the last that still has the chance to act. The tools are in our hands, the data at our fingertips, and the future waiting for our decision. In protecting Earth, we do more than defend a world. We prove that life, when conscious, can protect itself. Beyond the blue curve of Earth, the stars continue to burn, patient, eternal, unaware. Yet among them there is one small world that now watches back. Humanity has found its voice in the silence of space. The message is simple and it echoes into the dark. We are awake.